All right, string join by Matt Davis. So create a type-safe string join utility, which can be used like so. So this is fun because this is like one of the first challenges in a long while that actually feels like something I would use in a library if I had a joiner and I wanted the literal values to come out in TypeScript. I would use this. So you can put anything in there. If we take the challenge, we see a lot of the different base cases. So if there's no value, then we just return empty string. If there's one value, we return the one. But past one value, okay, if there's no delimiter, we handle all the edge cases first. If there's no delimiter, then we just return the join. But here's the first nice one, happy path. If there are two values or more, then we put the delimiter between them. And I think it's pretty straightforward, probably what the behavior is. This is a little different because usually we're working with types, and here we have to do declare function because they're all using like actual JavaScript functions. But it should feel mostly the same, I hope. Where would you start off? Like, what would be a base like approach?
So first thought is we need some kind of let's see. Actually, can you? So thinking through it, need to kind of split or map over the input, the parts. For each one, we're going to be returning itself plus the delimiter unless we're at the last part, because we're just going to return that with no delimiter at the end. That one's the easiest thing to do here, I think.
Okay.
Parts.
How about this? Can I give you like a setup for that, for exactly what you just described?
Sure.
You can't say no. That's a good offer, right? So let's make a separate type. So the first thing we need to do is grab these values literally, and the only way to do that is with generic constraints on the function. So we can do delimiter extends string, and then I guess we got to put this on a new line. Wonk wonk. Okay, and then this is going to be delimiter. Thank you. And then the same thing here, this has to be generic as well because we don't know in advance what the actual things what the parts are going to be.
Right.
No, I don't want lowercase. Okay. So parts extends, and then this would be like, you're tempted to say string array, but it has to be read-only string array because that's how you declare a tuple. And then here, it's going to be parts. And then what it returns, we have to go on to another line. What it returns, maybe we should just put the line here. Let's do this. Some of these challenges, it's like there cannot be a good way there's like no good way to form this. So then we're going to pass in. Now that we have those things, then we can pass it into a regular thing that we're used to. We have the parts in the delimiter. Maybe I should put them in the other order. If you do like data first, or data last rather, so we can be functional programming nerds. So delimiter is extends string, and it's equal to, we can just initialize it to nothing. And then parts, maybe we don't need to initialize it, but that's okay. Extends, same thing as before, read-only string array. So, okay, we're all set up, and now we have T. So we can start grabbing things from parts. This is like a tuple, so we can say like P extends. I think we're almost done with the setup. We'll put like infer head. We always use head and tail in the challenges, and then infer tail. We'll grab those out for now, and then we have like the true and false branch here. Parts. Sorry, I should have said parts. Okay, so
can we flip that around? Can the head be the array and tail be the last one? Just thinking through, because we want to split all of them until that last one.
Okay, sure. Happy to try that. What is the problem here? Required type parameter, it may not follow an optional type. Oh, okay. So like,
because you initialize delimiter.
There?
Yeah.
Okay. It doesn't really matter because we're always passing it, I think. Yeah. Whatever. Okay. Let's put these on the same line. Might as well. All right. So now, just conceptually speaking, where would you go from here?
So I'm trying to figure out how to actually. Oh, well, here, because parts do. Oh, I was like, how do you split that string apart? It's already an array coming in because it passed. Yeah,
because we use the dot 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 on the args. Exactly.
So in this case, our false on 48 should probably be a never.
Okay.
And then on 47, we're just going to have a temp. Well,
I mean, for one thing we want to do is tail extends. I think we want to do something like this, because what do we do
when it ends?
Yeah, when it ends.
So in this case, tail though isn't going to be an empty array because it would be the last. We're not accumulating into it.
Oh, right. Okay, so
I flipped you around. If you want to reflip it.
No, I mean we can. Well, whatever. Yeah, let's. Oops, I zoomed. Let's do that.
Trip you up more than this tripping me up.
Sorry, my brain is just used to working with the like front to back. Right.
So if tail is empty, we processed everything, and we can return. Should just be head then, right? Else we're not done and keep going. And then this will be.
So, I mean, now we can build up the actual thing. Like, this is the moment we've been waiting for, right? We can put delimiter and then like.
Because we're pulling the first letter off, we're adding delimiter, and then recursing through of tail.
Yeah, exactly. The recursion happens here. Okay. So what is the error here? Head is not assignable to string. Okay, so we can get around this a couple ways. We can do a union with string. We can also do like head extends string and like go down another level, but I think it's fine like that. And then it's telling me the same thing. Tail is unknown array. So we can fix this a couple ways. One of the ways we can fix this is by making a constraint here. I think, okay, good, that works. Then it's just, it's always going to be a string array. I don't know if somebody in the comments could please tell me. I don't know why this happens. We set up here that parts is a string array, and we checked, like, tail should be only one of two things here. It's a string tuple rather, or it's an empty tuple. We checked whether it's an empty tuple here. So like, it's not an empty tuple. By the time we get here, it's not an empty tuple, and it definitely is a string tuple. So why do we have to say this part at all? Because it's already specified by the type of parts. I don't get it, but that is the solution. Okay, sorry.
Can you add it on line 50 instead? I mean, it's effectively do the same thing, but could you do it on line 50?
Yeah, let's look.
String or read-only string?
I mean, that was saying empty tuple before, so I think we have to flip. We have to flip these cases. And then we can get rid of this. Same baloney. Yeah, it doesn't like it. So yeah, whatever. It's just a thing that we got to live with. Oh, there we go. Okay, everything passes except one. What is this one? So let's go up A1. So the type of it is never. So what did we do? Maybe, okay, this is the only place we have never. It's expecting empty string. So without even thinking about why this could work, let's put, okay, it works. That's how you debug, folks. Just look at what, without even trying to understand why it should be.
We had the test first. The test failed, and just make it happen.
Right. So just reading through it, like, okay, if this doesn't satisfy because there are no more values, then just return empty string. Meaning we could also do this by saying in front of all this, we could say like parts extends empty tuple, and then we could say like this, else, that stuff.
And then keep the never.
And then keep the never. Yeah, that also passes all the tests. So whatever, but
avoiding the nested extends is always nice.
Yeah, and like that's just how it works. Okay, that's cool. So we did one of the solutions or a variant. It's not exactly like what I found, but it's close. I want to show another. There's this person who solves the challenges. Their GitHub handle is UID11. They do really good work, and I'm really happy to see whenever I see that they've solved one, because it's always going to be interesting. They took the approach of splitting things up. So let's just go, like, we'll read from the top down. So we have join. They called it delimiter. Okay, so they use the generics. They use the generic here. Okay, so far we're exactly the same as our solution, just with things renamed. Then we get into join. So we have our tuple, we have our separator. They handle the empty tuple. So, okay, fine. That is what we did. They didn't have to do it that way, but we saw it. And then we see if the tuple has only one element in it, meaning there's only one thing, we just return it. So that's another kind of edge case that's being handled. And here's where the like good stuff is. So we grab the first thing off of the tuple. We know that there are at least two. We handled 0, we handled 1. Right. There are at least 2 in the tuple now. So we grab the first one, we put in the separator, and then the rest of them we pass into join recursively. And we do that by using tail. So tail, let's go up here. And tuple, I didn't say. Tuple is just an alias for read-only string array. So every place that you see tuple here, we could have just put read-only string array. But I think it's just nice because it makes it cleaner. Tail is a very simple, I think this is one of the previous challenges as well. It grabs unknown. I mean, we don't care about what the first thing is, so we just put unknown, because who cares? You could put anything here, could put string here, and it would still work. It doesn't matter for our particular case, but this is a more general purpose solution. And it will just infer rest and return the rest. Otherwise, if it's an empty tuple, it will return. It already handles the case. And that's it. It's pretty clean, and I think it's pretty nice to see. It's unfortunate that we have to have all these edge cases handled. But once you actually see where the recursion happens, I think it's pretty clear that we have the first value, the separator, the rest of the values.
Agreed.
Which do you like more, the solution we came up with, or this one?
No, I like the other one.
The UID one? Yeah, he does good work.
Yeah.
Or she, I don't know. And it's pretty cool. It's pretty cool to see things split up. And almost always, when you see solutions and they have helper types, you know it's going to be a good one, because it's really nice to be able to split up the different cases. And they even went so far as to show what these things return. I think it's really, really super cool.